All right, applied precalc. So we're going to really get into it today. We're going to look at mixed and entire radicals. So before I get into that, let's look at an example here. If I give you a fraction like this one, 96 divided by 384, you could solve with your calculator, but just looking at it, it's pretty daunting. It's pretty heavy to look at, right? But what we could do to make this easier, if I was presenting this number to you, I could have reduced it, and you'd understand what I'm talking about much better. If I reduce this fraction, it's just 1/4. And if I said, hey, 1/4, you immediately have lots of ideas, 0.25, 25%, a quarter. But if I say 96 out of 384, it doesn't quite make sense. So reducing is really useful in terms of fractions. Guess what else we can reduce? Radicals, roots. For example, I could ask you to solve the cube root of 24. Now from our last lesson, you could estimate it if you wanted to, but I'm going to show you how you can reduce that radical, turn it into something that we call a mixed radical, and it's another easier way to look and understand what kind of number we're dealing with. So the first thing I'm going to do, and the more practice I do, I can start to do this in my head, but for now I want you to be writing this stuff down, is because I have a cube root, I'm going to take the cube of a couple of numbers, starting from 0, moving on up. I'm going to take 1, 2, and 3, because cube root, or 0 cubed is just 0. But 1 cubed is equal to 1, 2 cubed is equal to 8, and 3 cubed is equal to 27. Why am I doing that? Well, I want to see if any of those numbers fit into 24. 27 doesn't work because it's too big. It's bigger than 24. So we can immediately say that that last one is not valid to us. And we know that 1 cubed is going to work because you end up getting 1. So last resort, we can deal with the 1 cubed if we wanted to, but it's not really going to help us. What might help us though is any other number. And in this case, we have 1. 2 cubed is equal to 8. So the next thing that we have to do is we have to test if that number, first of all, is smaller than whatever's inside of our radical. If that number is smaller than what's inside of the radical, we got to see if it actually goes into the number in the radical. So I'm going to divide 24 by 8 and see if we get a nice number. And as it turns out, this won't always be the case, but as it turns out in this case, 24 divided by 8 is equal to 3, which is a really nice number. It's not a decimal, it's not represented as a fraction, or a rational number would be awful. It's a nice whole number. So that means that if my cube root of 24, and 24 can be divided into 8 and 3, right? Because 8 times 3 would give us 24. It means that our cube root could become the cube root of 8 times 3. Again, because 8 times 3 is equal to 24, which is what we started with. I haven't solved anything here yet, I've just changed what my problem looks like. Now, if you're wondering why I did this whole table here, it's because I'm trying to figure out if there's a perfect cube inside of my radical. And it turns out there is, there's an 8. So when we come into this situation, where we now have the cube root of 8 times 3, I can actually solve the cube root of 8 because it's a nice number, it's 2. What that allows me to do is to take the cube root, or whatever type of root you're dealing with. In this case, it allows me to take the cube root of only the pieces that I can actually take the cube root of. I don't know what the cube root of 3 is, but I do know what the cube root of 8 is. Cube root of 8 is 2. So by solving that, I know that the cube root of 8 is equal to 2. The 2 comes outside of the radical. I don't know what the cube root of 3 is, so that stays inside of the radical. What I've done is I've created what's called a mixed radical, or a mixed root, because I have a regular number in the front and my radical after that. How does that help in terms of estimating or solving this type of problem? Well, now I know whatever my number is going to be is 2 times whatever I estimate the cube root of 3 to be. Just as an aside, you don't need to get this down, but a mixed radical is the same kind of thing as a mixed number, which you would have seen all throughout middle school, I imagine. I recommend pausing the video here and trying both of these examples. Try to turn that square root of 18 into a mixed radical, and try to turn this mixed radical, 2 times the cube root of 9, back into a whole radical, or a whole root. And just so you can see the solutions, for the square root of 18, I didn't quite know how to break it apart, so I looked back to my pre-cal and I remembered that we had factor trees. So I did a factor tree of 18, I got 9 times 2, and 9 can be split up into 3 times 3, which tells me that it's got a perfect square in there. So I end up doing 9 times 2 inside of my radical. Because 9 is a perfect square, it means I can take it out if I take the square root of it. Square root of 9 is 3, so the 3 comes out. Can't work with the 2, so the 2 stays in my radical. For the other example, I had a 2 on the outside of a cubed radical, cube root of 9. So if I want to put the 2 into the radical, it means I need to take 2 cubed and put it in. So that's what I've done over here. I have the cube root of 9 times 2 cubed. 2 cubed is equal to 8, so I end up getting the cube root of 9 times 8. 9 times 8 is 72, so that equals the cube root of 72. This stuff is hard. I've got some practice here for you to try out. Definitely do that, spend some time on it, and give me a shout if there's any issues whatsoever.